Every day we go into TAM, there's something new and cool to figure out.
One of the things most people may not realize about 3D printing concrete is that it requires a unique set of additives that allow for the cement mixture to pump nicely as a liquid while it is in the hose, but yet to hold firm when building layer upon layer so it doesn't fall over before curing. What this means to put all these additives in the mix is that this type of concrete or mortar will tend to behave differently than regular concrete. It generally shrinks quite a bit more, which can lead to cracking. In many cases this doesn't matter because the printed parts are only meant to work in compression, so the cracks are inconsequential, a cosmetic issue. Sometimes however people may choose that their parts will be designed to work in tension, such as roofs, floors and bridges, or other types of loading conditions, such as wind gusts or mitigating earthquake resistance. This requires reinforcements such as steel rebar or other internal elements to hold the concrete together.
We conducted flexural tests on blocks we 3D printed. The first had no reinforcement at all. The second had 25mm lengths of loose fiberglass thrown into the wet mix before printing. It was almost double the strength. The third test, we laid continuous fiberglass roving in some of the printed beads. The layout almost doubled again the previous test with the loose fibers. So we decided to make a machine that could do this while we print.
TAM is the first company in the world to make commercially available a robotic method to insert fiberglass, carbon fiber, aramids or other spool type reinforcement materials right into the 3D printed bead. The taller system that I helped to design took the team over 2.5 years of prototyping, trial and error and continuous development to finally get right.
Here we have one of our prototype versions of a roving feeder. We want one continuous length of fiber through our print, makes the strongest print. So the goal is to always have stronger prints and strong concrete that lasts a long time. So we've been playing around with this system and coming up with new ways of adding this roving.
There is a metaphor in English about futility of pushing rope, but that is quite literally what we had to figure out how to do, and we achieved it. Here is a little bit about our journey to get there. We designed a designated module in which a feeder was installed, much like for example your automated welding machine. That takes the tool center point speed of the robot motion and matches that with the roving feeding speed. We had to design a placement for the spool holder and a routing technique that would take the roving and transport it to the end of the print nozzle without it experiencing too much friction. Another challenge we had to conquer was to prevent the roving from getting stuck inside of the module. It would get tangled in between the wheels we used to push the roving out. We had to overcome a lot of bad parts and messy tangles to overcome these issues for it all to get working.
One of our clients is responsible for several hundred kilometers of underground water and sewage infrastructure. They often have to perform emergency excavations to access valves that are not properly performing. They asked us if it was possible to design a chamber that is a standard manhole shape on top, but is larger at the base so workers would have comfortable workspace. The infrastructure would also see at times heavy side loading from soil and hydrostatic pressure related to rising groundwater levels. We used parametric design to create a shape that was rectangular on the bottom and that grew to a standard manhole cylinder to receive further manhole extensions. Our part came in at about 25% of the cost of a custom part from a standard concrete supplier. It is about 40% of the mass of the comparable cylinder without the extra workspace ours offers them. And the structural integrity is about 400% stronger than current designs used by most water utilities.
The results are very pleasing. The additional tensile strength that comes from reinforcing printed concrete this way is going to be a huge game changer to the industry.